What up? It's your man, Jimmy Chan. All right. So let's talk about LabWork 12. All right. So here we go. Number 1, square root of negative 64. So one of the things that every time we do this, we always talk about what's the index, right? And the index, when there's no number, is a 2. So we're looking for pairs, right? So in this case, I can break down square root of negative 64 by saying this is the square root of negative 1 times 8 times 8. Or you can even go further, which the way I teach it, you go further. So let's go 2 times 2 times 2 times 2 times 2. I'm getting those really close here. 2 times 2. Whoa. 2, 4, 6. There is 6 of them. And there we go. All right? And don't forget, to get that, you would just do 64. 2 goes into 64 32 times. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 2 times. So there's 1, 2, 3, 4, 5, 6. And that's what I should have right there. 1, 2, 3, 4, 5, 6. Okay? So that is the case right there. Perfect. All right. So that's how you would get that everything into primes. All right. So with that being said, let's take a look. I have a pair of 2's here. I have a pair of 2's here. And I have a pair of 2's here. Right? And then don't forget that this right here, the negative 1, is going to give you an I, right? And then I'm going to have times 2 times 2 times 2. So we got perfect sets of pairs, and the square root of negative 1 comes out as an I. So that is it. So what I'm going to have is a 8i, right? Which is an imaginary number, right? Which is not real. So when you look at your choices, you don't have 8i. So therefore, it must be choice D, because 8i is not a real number. And there you go. All right. On to number 2. Number 2, if you notice that the index is actually a 3. So we're looking for 3 of a kind. Okay? So let's go ahead and break these down. So I got negative 3 times negative 3 times negative 3. And that's negative 27. Right? And notice that I'm putting in 3 columns as well. The A is going to be A times A times A. That's 3 of them. A times A times A. That's another 3, so that's 6. A times A times A. That's 9. And A times A, so that's 11. Right? So if you count it, there should be 11 A's right there. I'm doing columns of 3 because the index is a 3. All right. And then I have B, 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 and B. So there's 7 B's right there, okay? And this is the Q root, okay? So that's what I have. So I'm looking for triplets or 3 of a kind. So right here, I have 3 negative 3's. Right here I got 1, 2, 3 groups of A with 2 A's left over. right? And then I have a group of B with a B left over. With a B left over. It's like I'm on repeat. All right, so what do I have? So looks like I have some that's going to be staying inside because they're not complete groups of 3, right? So what comes out? Well, the negative 3 comes out. How many groups of A's comes out? 3 of them, so A to the third. How many groups of B comes out? 2 of them, so B squared. And then I'm going to have what's left inside. I'm left with A squared and a B, all right, which is the 2 that are circled. So that would be my answer. And that, ladies and gentlemen, will be choice C. There we go. That's number 2. Number 3. Ooh, rationalize the denominator with monomials. So we talked about have and need, or haves and needs, I should call it. Let's call it haves and needs. Okay, so one of the things we did right off the get-go was to split these 2 things here. So we actually have the cube root of 4 over the cube root of 9x squared, right? And we said that that would be equal to the cube root of 4 over cube root of 3 times 3 times x times x, right? So we're going to break down that bottom into their primes, and that's exactly what we have, okay? So what do we have on the bottom? So I talked about have and needs, right? So what do we have? Well, we have 2 3s and 2 x's. Since the index, is a 3, right? So that means we're looking 3 of a kind. Okay. So if you notice, I already have 2 3s. I need a third 3, right, to make that 3 of a kind. And I need another x to make that 3 of a kind. And what am I talking about? I'm talking about right here, guys. You know what? That would be... So if I put these together with what I have and what I need together, I'll have 3 3s, 3 of a kind. And if I put the x's together of what I have and what I need, I'll have 3 x's, right? All right, so I'm going to multiply top and bottom by what I need. So this is going to be a cube root of 3x. I'll multiply that on bottom, and I'm going to multiply that on top as well. There we go. All right. So what do I get? The top, since they're both inside the house and they're both cube roots, what I'm going to have here is the cube root of 12x. What do I have on the bottom? Right? So the bottom, if you look at this, so let me highlight this again. So again, if I put all of this together, actually, better picture. If I put this, which is what I have, and what I need, I should have this whole thing right here, right? So if you notice, I have 3 3's and 3 x's. So if I have 3 3's and 3 x's, that means I have a 3 that comes out, and I have an x that comes out. And voila, there is my answer. And that is going to be choice B. Go. There we go. All right, and that's number 3. All right, number 4. Oh no, rationalize the denominator with a binomial in the denominator. Okay, so what I gotta do is what I'm gonna do is, number 1, I'm gonna put parentheses around my binomials. Okay, and notice the word conjugates here, right? So in order for me to get rid of that radical in the denominator, what I would do is multiply top and bottom by the conjugate of the bottom, because the bottom is what I want to get rid of that radical. Okay, so yes, I will have to distribute the top and FOIL, or actually FL the bottom. So what I'm going to get on the top is going to be a 5 square root of 10 plus 30. Okay, that's distributing the top. And then the bottom is going to be just a 10 minus 36. Because all I got to do is FL the bottom, which is first and last. So I got to really literally do first, which is square root 10 times square root 10 is 10. And then last, which is negative 6 times positive 6, which gives you the negative 36. Okay? Boop, 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 boop. All right, so what do I have now? I still have the 5 square root of 10 plus 30, and that's going to be over, negative 26, right? So with that being said, I don't like that negative. So I have 2 options of writing this particular answer. And so let me slide this over. So there's 2 ways of writing this answer. So I'm going to show you what those 2 ways are, because you're going to wonder why it isn't one of these answers. Okay, so let me put down an arrow here. That's too long of an arrow. And then the other one, let me see if we do this. Yeah. Ooh. Yeah, that will work. Okay, so the first way of doing it is going to be putting it to the top, right? Because we don't like negatives on the bottom, so we're going to move it to the top, but we got to distribute it through. So essentially what we would do is we have this negative, and we move it to the top, but then we're going to distribute this. Okay, so when we distribute this, what happens? Well, the top is now going to become negative 5 square root of 10 plus, minus 30 over 26. That would be a correct answer. However, if you decide to just put it in the middle, actually that doesn't even look like a negative. If you decide to put it in the middle, that's certainly fine too. Then it doesn't have to be distributed. Which is exactly what the answer actually is, which is choice D. But both are acceptable answers, just so you guys know, and that you're not surprised by it if it shows up. Okay? That's number 4. Number 5. Ooh. It is still rationalized the denominator because I have a 9i, because of the I in the denominator, but it is a binomial. So first of all, I like my parentheses around my binomials, right? It makes it a family. So I want to get rid of the I in the denominator. I don't care about the I in the numerator. It can be there. It's the I in the denominator. So I would want the conjugate of the bottom. So I would multiply top and bottom by 4 plus 9i. Yes, the top you have to FOIL, but the bottom you just have to flip because they're conjugates. Okay? Boop, 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 boop. All right, so what do I have on top? The top is going to be a 16 plus 36i plus 36i plus a 81i squared over, let me see, a 16 minus 81i squared. Okay, so that's what I actually have. All right, but what do you notice about I squared? Right, I squared is actually going to -1. So the top, let me see what I want to do here. Let's do this. Boom, 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 boom. Boom, 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 boom. So again, the I squared is a -1. So essentially, this is now, this I squared is going to take out that positive and make it negative. And this I squared is also going to make this negative a positive, right? It's going to flip the sign because it's -1. So -81 times the -1 would be a positive 81 now. All right. So with that being said, what do I have? I have on top the 16 minus 81, right? And that's going to give me a -65. 36 plus 36i gives me plus 72i over 16 plus 81, which gives me 97, right? But it wants it in a plus bi form, right? So that means what I have to do is actually split up this fraction. So when I split up this fraction, what it's going to be is going to be -65 over 97 plus 72 over 97i. And that would be choice C. And there we go. All right, so that's number 5. Number 6, and plus, if either one of these fractions can reduce, you would actually reduce them, okay? Just want to throw that out to you so you guys know. Number 6, oh, it wants the quadratic formula. So hopefully you guys all got onto YouTube and typed in quadratic formula song and got a song in your head to remember the quadratic formula, because you actually need to remember that on the exam. So the one I always sing in class is x equals -b plus or minus square root of b squared minus 4ac divided by 2a, right? So and that is actually a Notre Dame fight song, and I don't think you can find it on YouTube. That was done by an old classmate of mine, or teacher mate, I guess I would say. That taught across the hall from me, and he put the quadratic formula into almost any song that he can think of, and that was the one that got stuck in my head. All right, so with the quadratic formula, what I gotta do is look at ax squared plus bx plus c is equal to 0. So I gotta identify my a. So this one, the a is gonna equal to 1. The b is gonna equal to positive 14, and the c is gonna equal to positive 74. All right, so here we go. X. Let me do this. Let me bring this all the way over here. X is equal to -b, means negate b. So that's going to be what? -14 plus or minus the square root of b squared minus 4 times a times c. And that is all over two times a. Okay. So one of the things I say to you guys in the notes is this. When you plug anything into the calculator, this is what I would suggest, that you only plug in what's underneath the radical. Okay, plug in what's underneath the radical. So I would do 14 squared minus 4 times 1 times 74. So I'm going to show it to you right now with Desmos test mode, with the scientific, start practice. So what was it again? It was 14 squared. So 14 squared, right, minus 4 times, you can use parentheses as well, 1, which is a, times c, which is 74, okay? And you got negative 100, okay? So that's what you would do. So you will come in here and say, okay, that's equal to negative 14 plus or minus the square root of negative 100 all over, hopefully you guys can do 2 times 1 in your head. So we got that. There you go. All right, so what does that give me? Right, so if I think about the 100, well, let's bring it down. So x equals negative 14 plus or minus the square root of it'd be negative 1 times 2 times 2 times 5 times 5 all over 2, which I can make this radical a little bit shorter here. There we go. All right. Okay, so what do we have? The index is a 2, so we're looking for pairs. We got a pair of 2, a pair of 5, and that negative 1. So that's actually going to come out to be negative 14 plus or minus 10i all over 2. Then what happens is that we have a triangle here, right? That negative 14, the 10, and the 2. Something goes into all 3. What goes into all 3? 2 does. So 2 goes into negative 14 negative 7 times, plus or minus. 2 goes into 10 5 times, and 2 goes into 2 once. So since the denominator is 1, I don't really need to deal with it. So therefore, that's going to be choice C. There we go. All right. All right. That was number 6. So on to number 7, the square root property. And you guys probably got confused about that. You're like, what's the square root property? Actually, square root property is something that you've been using since, in the middle school, maybe even earlier, especially when you guys were using Pythagorean theorem. All right. All the square root property is saying is get the squared by itself, right? So I would subtract the 9 over to the other side. Okay. And then what I would do, since the square is by itself, I want the opposite operation of squared so that the x squared would just become an x, because that's what I'm solving for is x. So I would take the square root of both sides. The problem with taking the square root of both sides, though, is that when I take the square root, there has to be a plus and a minus. Okay? So that is your square root property. So that is this. All right? So on the left side, what do I have? I have just an x left. On the right side, I got the plus and minus the square root of negative 1 times 3 times 3. I have a pair of 3's. I got the square root of negative 1. So this is going to be x is equal to plus or minus 3i. That means I have a positive 3i and a negative 3i, right? And that is going to be choice number B. There we go. Excellent. Excellent. All right, there we go. All right, on to number 8. So this one is kind of like part of completing the squares, where I got to find a new c and I'm going to factor that. So to find a new c, so c is equal to b divided by 2 squared. Okay, the b is negative 1/3. Oh, see, positive 1/3. I'm sorry, is the 1/3 divided by 2 squared. Well, that would say that it's equal to 1/6 squared, which is equal to 1/36. I know that looks like a B. There we go. Okay, so that means this part right here is going to be 1/36. And it wants you to factor this piece right here. All right, and that piece right there is already factored for you, right? Remember how I told you to show the work? Because if you show the work, then this is already factored for you. Okay, because it comes right from here. All right, so since it's already factored for you, you already had the answer, so that you don't actually have to try to factor that trinomial right there, which I'm sure would be a little bit difficult, but you don't need to actually solve for it. It's already solved for you. Okay, so then that is going to be choice C. And there you go. All right, on to number 9. Ooh, completing the squares. All right, so first of all, I got to get in the standard form, right? So x squared plus 16x plus 51 is equal to 0. Okay, so I got to bring that 16x over so it becomes a positive, right? And step 1 says a has to equal to 1. Well, a is already equal to 1, so I'm good. Step 2 says to move the OC over, so I got x squared. Actually, let me do it this way. I got the x squared plus 16x is equal to negative 51. So the blue is to show that I moved the OC over. The purple is to find the new C. And the purple, the new C, is equal to 16 divided by 2 squared, which is equal to 8 squared, which is equal to 64. So now I have to add it to both sides. So I add 64, add 64. So my next step is to factor the left side. Oops, maybe I should have done this in... I did this on purpose, and I still screwed it up. All right, so when I factor the left side, I'm going to have x plus 8 squared is equal to 64 minus 51. What is that? 13? Is that right? Okay. So last thing to do is to solve. So to solve this, let me bring this down. Let me bring this over. In order to solve this, I'll have to take the square root of both sides, But when I take the square root of both sides, I have to have that plus and minus, right? So left side is going to be the x plus 8. And it's going to equal the plus or minus square root of 13. Well, I can't break down 13. 13 is a prime number. So all I can do is bring that x over, bring that 8 over, so I can get x by itself. So it would be negative 8 plus or minus square root of 13. And that's two answers, right? It's negative 8 plus square root of 13 and negative 8 minus square root of 13. And that, with that being said, that would be your choice A. Let me bring this down a little bit before I box it. Boom, boom, boom. There we go. All right, on to number 10. So quick. All right, so it's already in standard form. So step 1 is to get a to equal to 1. So in order to do that, I have to divide everything by 8. So I get x squared minus 5 over 8x plus 1 over 8 is equal to still 0. Step 2, move the OC to the other side. So I have x squared minus 5 over 8x is equal to negative 1/8. All right, step 3, find a new c. So c is negative 5 over 8 divided by 2 squared, which is equal to negative 5 over 16 squared, which is equal to 25 over 256. So I have to add 25 over 256 to both sides. Okay? So the last one is a factor the left side. So when I factor the left side, it's going to be x minus 5 over 16 squared is equal to, well, like I said, I don't mind you guys using the calculator for this. So what was that, 1/8? Oh, negative 1/8, right? I got such a great memory. Negative 1/8. So negative 1 divided by 8, get out of there. And I got to add 25 divided by 256. It's a decimal, oh no. Change it to a fraction by hitting that button right there. I get a negative 7 over 256. Awesome, so I have a negative 7 over 256. Okay, so again, got this. Last step is to solve, right? Okay, let's do that. So this is where the square root method comes in too, right? So got to take the square root of both sides. But when I take the square root, I have to have the plus and minus. So the left side is just going to be my x minus 5 over 16. And the right side, it's going to be plus and minus. Let's leave that alone. The top is going to be the square root of negative 1 and 7. And the bottom is going to be the square root of 256. Now, 256 we got from over here, which is this bottom right here, which is a 16 squared. So that means the square root of 256 is actually going to come out very evenly, or perfectly, I should say. So I'm going to have on the left x minus 5 over 16, and that's going to equal to, let me make this a little bit smaller so that it actually looks somewhat similar. All right, so what's going to happen here? Well, square root of negative 1 times 7, well, 7 can't break down anymore, but the square root of negative 1 is going to be I. So it's going to be I square root of 7 over square root of 256 is just going to be 16. Awesome. So now, oh, don't forget the plus and minus. All right. So now x is going to equal to, if I add the 5 over 16 over, so I got 5 over 16, so it would be positive, plus or minus I square root of 7 over 16. So I got two forms here. I can either get the a plus bi form or a single fraction form. Since it doesn't ask me for a plus bi form, then this is just going to be x is equal to, now, this is the same thing as adding, subtracting two fractions. Gotta get common denominators, which we have, right? When we have common denominators, what do? We keep the bottom, and the top we add or subtract, which is 5 plus or minus I square root of 7. And that is choice A. And there we go. Oh, too close. Okay, boom, boom, and there we go. Let me move the A in the center. All right, so there we go. Here is LabWork 12 answer key. If you have any questions, let me know. See ya.